Okay, are we about ready to start our final session? I think probably we are. Francesco, is this good for you?
Sure.
Okay, well, we decided to have a final session where we could not so much sum up what the workshop had thrown up, but what the future might offer us. And for my part, certainly there are a number of very exciting things that we could all be doing as a collective community. But I have asked a few people by email if they'd be prepared just to throw in some ideas following on from the workshop. What should this community be trying to achieve and how it might go about it? And I wonder whether I could go around them individually and just ask them to say for a few minutes that their kind of top level ideas for where we can go next. Really not picking in any particular order, but perhaps I could begin with Mike Tobar. Mike, have you got some thoughts?
Oh, yes, thanks for that. And thanks for inviting me to give my thoughts. Yeah, so I think it's a very interesting topic. I believe that there's, in my opinion, there's just because I think it's most likely that there will be high frequency gravity waves. A lot of people in the gravity community do not, but the universe always throws up surprises. So I think it's with a lot of the gravity wave community skeptical about them being high, that they would exist. I think we have a good advantage that we can get involved and maybe make a huge breakthrough. So it seems to me that the cavity ideas can achieve good sensitivities, but so we've definitely got that sort of technology, and we're interested in doing that, considering the background of our lab in resonant bar detectors, a lot of similar technologies. So I think but I'm a bit confused about two talks with a DC background field and different modes that are sensitive. So there doesn't seem to be a coherent theory behind it that gives us the sensitivities. Maybe that's a problem with general relativity, because I also have a meeting with Raymond Chow once a week, and he's got some really out there ideas with high frequency gravity waves too, with levitated graphene sheets and things like that. Yeah, so I believe that, and I also believe that the noise sources is probably really when you get into the experiment and start running, it's really good to get prototypes running, because that's when you find out how sensitive you can be. And that was the history of the resonant bar detectors. First, they went in room temperature, then they went to cryogenic, then their transducers didn't have enough electromechanical coupling. They invented the multi-mode transducer. You only find these things out when you do experiment. So it's very important that prototype experiments get up and running quickly. That's what we did with we didn't go as quick as we wanted to with the quartz. So a resonant bar detector is well known. There was a few in this, there was a few discussed. I wasn't sure of the different ones that were discussed with trapping and the Bose-Einstein constant states, which were effectively resonant bar systems. And then there was that nice talk on phonons, which Maxime and I discussed. And we just thought it would give the same result as a resonant bar cross-section. It should do. So there needs to be some convergence of on the theory that's developed, I think. They're just some comments I have. But I think prototypes is the way to go.
Okay, that's very good. And it has been great having contributions from New Zealand and Australia at this meeting. I think that's been fantastic for all of us. So perhaps I could come to, I don't know if Andrew Garachi is online.
Yeah, I'm here. Yeah.
Hi.
Hi, thanks. Yeah, thanks for the invitation to speak at this panel and for all the wonderful talks and organizing this really interesting workshop. So it's nice to see how the community is kind of evolving after the past couple of years since the original meeting. So yeah, I mean, our interest, I guess, with our levitated particle sensor is primarily in the sub-megahertz sort of range. And I think it's interesting to think about as just to pick up on a couple of things that Mike said. It's interesting to think about prototypes at this point to sort of benchmark technologies, but at some point we may want to consider the benefit of having, assuming things sort of check out with this technology, the benefit of having additional sensors located at different hemispheres, for example, different continents, Europe, Australia, et cetera. And so going forward, it might be nice to think about a plan for what would be a sensible coverage in terms of maybe meter scale instruments, and if things are possible, even 10-meter scale instruments at some point in the farther future to sort of cover that band a little bit better. So I would welcome further discussions on that with folks who might be interested. And I think as the instrument is starting to be turned on, we're going to, as Mike pointed out, identify the real noise culprits once we actually try to take data with these things. And so that's going to be an ongoing process to sort of understand the typical noise sources in this higher frequency range. But along with that, we're also now developing a pipeline for source modeling and data analysis. And in the theoretical community, I think if there were some efforts to sort of sharpen predictions for signals, both from maybe stochastic as well as coherent sources in this range kind of going forward, that would be really useful as the instrument is commissioned and then eventually starts taking data, hopefully, if things go well, in as little as 2 years from now.
Okay, that's very helpful. And I think there are roles for the UHF-GW group in perhaps helping coordinate some of those things, or at least acting as a center for those ideas to be put forward and blossom. So that's very good. So perhaps I could turn to Axel. Are you online, Axel?
Yes, I am. Thank you. Thank you very much also everyone for this nice workshop, as I'm a newcomer to this field. I have maybe two thoughts. The first one is that I think we could also roll out a bit more to the particle physics community to really demonstrate what high frequency gravitational wave searches can do for particle physics. And it appears to me a quite unique handle to the early universe or to some black hole models. And this is I think it needs to be better communicated. If I look around at DAISY, of course, that's my microcosm, then not everyone is fully aware of this opportunity. And very frequently, gravitational waves are automatically associated with astrophysics, not so much with particle physics. And this, I think, we have to change. It might be also important on the midterm to do this really to get access to, let's say, frankly, larger funds, which are typically with particle physics. And I could very well imagine that in parallel to the next accelerator studies ongoing or the long run of LHC and the luminosity upgrade, that many particle physicists would be interested to also engage in other topics. At least that's our experience with axion physics also.
Okay.
And
yeah, carry on.
And the other thought, which was also discussed previously at this meeting, is that in parallel to to the working out of concepts of detectors and to working on theory and strengthening the physics case, it's, I think, important to come up with experimental results quickly, that we demonstrate outside our community, that we come to terms, that we publish physics papers, that we get experiments running. And we have seen many fantastic proposals and experiments on very different scales and very different stages. And again, I would like to point at opportunities like ALPS-2 and Baby Yaxo, where we have something running which could maybe easily also adapted to do better for high frequency gravitational wave searches. That's basically the things I would like to communicate, reaching out to the particle physics community, pointing out what high frequency gravitational wave can do for them, and also look at opportunities which are near term to get experimental results.
Great. Those are two very useful comments. Let's come now to Raffaele. Are you online?
Yes. So,
oh, good.
Thanks again for the invitation. Well, minimally, I would like to say that much of what was already done, I think, is very useful. For example, coming from outside of the community, I found that the review article that you wrote in occasion of the previous workshop was extremely helpful. I mean, it definitely gave the community visibility to me as an outsider. It helped me understand the different experimental ideas that already existed, the possible sources, etc., etc. So I think updating that as like a minimal next step would be useful. And also even just keeping up the workshop series. I mean, this format I think is great, where experimentalists can tell theorists that are being a bit too reckless with their background estimations, and vice versa, theorists can try to polish details of the calculations, etc., etc. I mean, this is all obvious, but I think it's a useful form of cross feedback. And secondly, yeah, I completely agree with Axel that we should try to show the particle physics community that in the end we're trying to do particle physics. I mean, this is probably the only way we can imagine at the moment to probe extremely high energies. And to some extent, the message is already coming through. I mean, I come from the particle physics community, and I see that many of the theorists here do too, but maybe on the experimental side, this has happened less. So yeah, for sure, that's something to do next. And finally, so I see some very notable US representatives here, but I was wondering, I mean, I think that the whole community in the whole world is not huge, so maybe it would be nice to also have occasions to meet everyone. And I mean, I cannot gauge properly, but I have the impression that this workshop is more Europe/Asia, Asia/Oceania, and maybe not everyone in the US was here, but maybe we can have less regular events also with a geographically broader set of people.
Okay, those are very helpful inputs. Francesco, your comments.
Yes, Mike, I would like to share these few slides that I showed you, in which I recap some of the things that have been said, some of the points that also were raised now. So I think that in this workshop, we basically had these 4 goals in mind. So basically to discuss the most promising technologies and to try to understand what are the first steps to plan the construction of prototypes. This is along the lines of what Mike was saying now. I think it's fair to say that we touched these 2 points basically in all discussion sessions that we had. And there are many interesting ideas floating around. Then we have also discussed how to facilitate existing projects with Yvette, Andrew, and others. And I think we will hear more about this point also during this discussion session. And then we also had a nice discussion session on theory and many interesting talks in which we have seen what is the potential of ultra-high-frequency gravitational waves. Now, many ideas came up, but they are not only words, because, you know, verba volant. The interesting point is that they translated basically spontaneously into concrete proposals for working groups. So I want to summarize them here so that people can join if they want these ideas. First one, we had from Juan. We had 2 proposals to explore the feasibility of a larger monocrystal gravitational wave detector along the lines of his talk, and then to study the physical requirement and sources of noise attenuation and signal to noise enhancement. We had the 3 proposals from Yvette. She can comment later. To adapt the detection method to superconducting circuits or other multimode bosonic systems. We are talking here about Bose-Einstein condensate detectors. Then she was proposing to develop a detection method for stochastic sources and to collaborate on a review on BC detectors. Then we had from Sebastian, he was proposing to keep analyzing and exploring the sensitivity of resonant microwave cavities for ultra-high frequency searches. From Andrew, we had two proposals to work out more detailed theoretical estimates for sources in the band below the megahertz, which is relevant to levitated sensors, and to explore, as was saying now, the possibility of having more than one experiment in both hemispheres. Then there is Axel, who proposes these two ideas to check whether ALPS is suitable for ultra-high frequency gravitational wave searches, and to check whether ALPS2 is suitable also for PBH, to detect PBH mergers. And finally, this is the only theoretical one that we had, but I think we can have more during the next days to determine and optimize the parameters for ultra-high frequency gravitational waves from first order phase transitions and topological defects best suited for a particular detector. And we didn't have time to add more ideas from cavities, since the talks were this morning. I just want to add here that we have a Google Doc that was created by Sebastian Klesse, which you can basically sign up for these ideas. This is the link, and we will circulate it later, both in Mattermost and via email. And there were a couple of additional ideas to create collaborations with the CERN quantum people and to get in touch with the Physics Beyond Colliders project at CERN. Concerning the living review, since Raffaele also raised this point, we have this review that has been accepted for publication on living review in relativity, and we have the possibility to update it every 2 or 3 years, including substantial changes. And the interesting thing is that we can also change the author list, so future contributions are possible from other people. And also for this, we have a Google Doc in which we can take note of basically all the changes that we plan to do during the next years. And please, since we don't want to pester people, if you are interested in taking part in all this stuff, please just subscribe to the Google group, and we will use that as a main channel of communication. I want to finish with a question for the audience and for the panelists and everyone. So far, basically, we have been a group of 8 people who have tried to advertise this idea of ultra-high frequency gravitational waves and to convince people that there is a huge scientific potential behind it. Now, the question for me, at least, is how this initiative should evolve in order to maximize the chance of success. For success, I mean having 1 or more detectors in this frequency band that is capable of eventually detecting something interesting. Of course, the working groups are one possibility that might lead maybe in the medium term to grant applications. And for sure, we would like to have closer and more frequent interactions with the people, especially from the experimental community, as also Raffaele was suggesting. This is it for me. Thank you all for the active participation in the meeting.
Can I add something?
Sure.
So I didn't have time to do any write anything down. This week's been hectic because I've had other SNOMAS Axion meetings and stuff. But I have 3 meetings with ADMX every week. One proposal, which is that ADMX runs sidecar experiments, and when I put it to them, they were all open to having sidecar gravity wave experiments. So I think that you might. There's room, and in the second generation of ADMX is even going to be a bigger volume magnet. If anyone knows the SNOMAS site on wave-like dark matter, Chelsea Bartram gave a talk showing the future, the next phase of ADMX, and it's a bigger volume, and they've already asked us to consider putting a higher designing a sidecar high frequency axion detector in there. But you'd have room for gravity wave, the sidecar gravity wave experiment.
Okay, thank you very much. Has anybody else got any comments they want to throw in? But not so much on the technicalities, but how the UHF-GW initiative should move forward, things that as a community we ought to be doing. I wonder whether anyone else, Juan, please.
Yeah, I'd like to make a comment. I think we are in a great time in the sense that we have a fantastic progress in quantum sensors and quantum metrology. And I think we should take advantage of the technological advances that have been done for detection of dark matter, which is obviously a very weak thing to capture. And all of these technologies can be transformed, as we've seen, from ADMX into gravitational wave detectors. So I think we should try to follow that line and see what kind of detection techniques have been improved in that area that can be converted into gravitational wave detector. And obviously, the one I have in mind is the one I presented with crystals, like the sapphire. Clearly, there is already space there for improvement along many different lines. So that was just a brief comment, because the rest you already have summarized very nicely.
Okay. Does anybody else wish to throw in some ideas and comments? Speak up. Oh, Fernando.
Yes, well, just to emphasize the point that Axel made, I think that this is a very important opportunity now that we have pointed out that there is a this issue that, I mean, there are all this potential for gravitational waves of high frequencies that will be exploring early universe, but also beyond the standard model of physics. And it's good to have people from different communities, but in particular, to convince the experimental community at the big labs like DESI and CERN, or even Fermilab, that this is a way to go, because also the labs, they also have to face their own future. And for instance, CERN will be delighted to get involved into something that detects something beyond the standard model. And and if we can get to them to in some one way or another, that will be, I think it will be very good for us, because the labs have their own resources. They have to think ahead in many years from now, and this could be one thing that they may have not thought about it, especially because we're just starting. So I think if we can make any effort now, it's good that CERN was the host of this event. So that means that the theory just can just permeate to the experimental part. And also we have very strong representatives from DESI now. So I think this is a good opportunity to make the case, and if we can all work together in one way to do that, that will be wonderful.
Very good point. So it follows up from what Axel was saying about, we need to be a bit evangelical about this and attend meetings and give talks emphasizing the opportunity here. Yeah. Valerie.
Actually, also wanted to follow up on that point. So I'm a particle physics theorist, and I can say that I think in my community it takes very little to get people excited. So I see no obstacles at all, right, in getting these people excited. But it's true that it kind of needs to spill over into the experimental sector, I think, to actually have an impact in terms of actually building a detector, and not just an impact in terms of number of papers on the archive. What I think that is important, kind of beyond what we are currently doing already, is to have some idea of the prospects or the possible scaling for the future, right? Because I think now, if somebody asks me, okay, like all these ideas that you're discussing, can they realistically detect any particle physics model that you can believe in your wildest dreams? Then at the moment, the answer to that is probably no. Right, but so it would be great to have, but then I always say, but we're only at the beginning, and some of these experiments operate on relatively low funding, and there's a lot of potential, blah blah blah. But to have something. We tried this already in the white paper, right? We kind of tried to get a feeling of what would be kind of the ideal scaling if you think you have a lot of money and you can maybe extrapolate a bit how you expect technology development to happen. I mean, this is what we do also for the FCC, right? I mean, the technology isn't there yet, right? We make a wild guess at what we think we can achieve, but it has to be somewhat substantiated, right? And to kind of have that thought process in a form that we can actually communicate it, I think would go a long way in kind of convincing a lab to say, okay, yes, I want to build this prototype, not because I think that this prototype can do physics, but because I actually see this as a path towards detecting new physics.
Okay, very good point. I think several of us are making the point that we still have a credibility gap, in all honesty, and we need to be active in trying to overcome that. I probably shouldn't say this in a semi-public form, but when I submitted a paper in, I think, 2012 about high-frequency gravitational waves, the editor of the journal wrote back an email saying, "Mike, this is very courageous." And I think he was meaning courageous in the kind of worst sense of the word, foolhardy, probably he meant. Anyway, Diego, you have a comment.
Well, can you hear me?
Yes, indeed.
Yeah, my comment is also related with something that I find is missing. Also, when we talk to the community of quantum sensing, we are missing in this white paper a dictionary. Okay? I think the language. I have a paper also on atomic clocks. Took us 1 year to find the language. So but once and it's not so difficult in the sense that, well, I guess you have more experience on that. But what people want is the Hamiltonian of interaction, something like this, which is something that you can derive. But for me, was something completely new. And then, so it would be nice to put it on. I think it was mentioned before, something that there is this. For a theoretical physicist, you have this EFT, so all these sets of interactions which are exciting, and then how do they translate into this spin action interaction? How does it translate into, and then in different setups? So you have one particle, you have a condensate, or these things. I think this would be very useful for both communities. Also, take what I was saying today on this frame thing. I mean, those things are known. It's not that we are doing anything new, but it took us, going back to old papers. I guess you see what I mean. This work was done by people, and it's kind of in different places. And this dictionary would be, I think, very useful to basically, in the next review, right? Yeah.
Thanks. That's a good point. Yvette, it was partially a point you were making before, but tell us what you think.
Yes, thank you very much for the invitation. When I first came up with this idea and I presented it, when there was people working on gravitational waves, they would just say there's nothing at those frequencies. And it was just like end of the conversation. And I was very excited to be in all the talks today and see when they said that, I really kept going, because I thought, I just can't believe that there's nothing. It's just, I don't believe the universe is like this. There must be something. So I'm really glad that I kept going. And now, was invited to come here. I also felt like I was interested in all the talks, which because of my interest, doesn't always happen at the conferences I'm usually invited to. So I felt like, okay, this feels like the right place for me to be at this moment. So thank you very much for that. And about what Diego said is that, yes, I think this language is building a bridge is very important. And I started to apply techniques of quantum information and quantum metrology to quantum field theory and curved space-time. So there I learned about this kind of common language. We were calling completely different things the same stuff, and it takes some time to just realize, oh my god, that's what the fidelity is. It's just the and it takes a bit of time. It's a bit silly, but it is funny that we use so different words to talk about the same things, or even different ways of looking at things. And we need the states, and in quantum field theory, everybody wants to look at the energy momentum tensor, you know, and because of the need. So I would just like to offer two things, and one is to Diego, that if you need some, you know, if you have some questions in that regards and I can help or point out to people I know that can help, maybe I could contribute a bit to, at least from the quantum side, building that sort of dictionary way of translating things. And the other is, well, my expertise that they basically, I would say, would lie in quantum metrology and that sort of thing. So if you need help from that point of view, maybe I can assist. I saw some of the projects that were discussed, and I thought, oh, maybe if they tried this with, you know, things that come up from my background. So maybe, you know, meeting together in that sense could be very, very helpful. And maybe we come up with a new sort of proposal that brings the best of different ones, you know, bringing in different ingredients. So yeah, that's all my comment. Thank you very much to everyone.
Well, thanks, Vivek. That was helpful. Hartmut.
Can you hear me?
Yes, indeed.
Okay. Yeah, just a comment related to enthusiasm maybe and credibility and so on. So as you all know, the gravitational wave detections we have today wouldn't have happened with people being enthusiastic about them 50 years ago, and the first efforts were kind of 6 orders of magnitude away. So what would be nice to see maybe is if we can generate a map over all frequencies and all experiments and all the theory that has been discussed here to show kind of how far away current experimental concepts, prototypes, future follow-ups are from actually predicted sources to give some sense of scale and maybe add to the credibility as well.
That's a very helpful comment. Yeah, thanks. Diego, you still have your hand up. Is that historical or?
Yeah. I have a comment on what Hartmut said. Can I?
Yeah, please.
Go ahead.
Go on.
So actually, I'd like to change the view a little bit, because the expectation for what LIGO Virgo should see was not what was seen. So they were expecting 10 solar mass black holes, and they found 30, 50, even 100 solar mass black holes. They were expecting very few neutron star events, and they're finding tens. No, okay, that is not yet published, but I'll tell you. This is not what is the expectation. And I believe, and I claim it's because there are new populations. So when you say, what are the expectations from theorists in this frequency range, one should be, well, careful, because what we believed should be there from astrophysics could be very different from what is actually there. And we should be bold in a way and explore regions which were not explored before, just simply because there's an opportunity there. It might be we just find something completely unexpected, like I claim has been found in LIGO and Virgo. So even if you're 6 orders of magnitude away, it's worth the effort. Very slowly going down, 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 down. Yeah. Same happened with the CMB discovery. There's so many different experiments that actually found things where they were not expected.
Yeah, thanks. That's a good input. It certainly resonates with people like us, but then, you know, this is preaching to the choir a little bit, and we do have to find concrete predictions to convince funding agencies and things. But I agree with you. I mean, my heart is with you completely, that this is an area of parameter space, and you must explore it. We don't know what's there. Now I have some more. Sorry, have I? Fernando.
I think Francisco was first.
Oh, sorry.
Yeah, it was just to follow on Hartmut's comment that we have updated already the review, including the sensitivities of the concepts that we described there, contrary to the first plots that we had. And we have something like this, if this is what you were referring to. So you see that for late universe sources, there are some concepts that are quite close to the interesting region for detection, while for the stochastic sources there is still quite a gap. If this is what you were referring to when you were saying you want to map.
Yeah, if I answer quickly, in principle, yes, though there are many orders of magnitude here, and so it's for an outsider, it's probably difficult to get a sense how optimistic any of these experimental realizations really is, because things like IAXO are not funded yet, and Jura is a conceptual idea, and yeah, there are many details to clarify, but in principle, yes. Thanks.
Fernando.
Yes, can I use that then as a follow-up? Like, because so what can we say? Because that paper about this is updated up to a few weeks ago. But after this workshop, how far can we say? How optimistic can we be about reaching all this bounds? For instance, a thing that I haven't heard before, like Rafael or Yvette, can you comment on that in your experiments? How far can you go in sensitivity and frequency?
Do you mean beyond what you already showed, or how strongly we believe in what we showed?
Right, because you stop at 0.1 gigahertz and didn't show more than 1.1. So how higher can you go there, and with which sensitivity would be the ideal?
Yeah, I think you can pretty much extrapolate those lines by eye to 1 gigahertz, and that should be okay. Beyond, I'm not sure, because at that point you start getting hit by the fact that the cavity volume is reduced. So very naively, you should the sensitivity should worsen as I was plotting the strain, so as the square root of the volume of the cavity, so as 1 over frequency to the 3 halves roughly should get worse like that, going to higher frequencies. To lower frequencies, roughly, well, you already saw in the plot that the sensitivity was not great there. It's gonna get, I mean, you cannot extrapolate the lines by eye because of that. Around where I stopped the plot, new sources of noise become important, and so it's gonna get worse even faster than what you see there. And even if you just extrapolate the line, it's not amazing.
So concerning you're optimal at the gigahertz, more or less.
Yeah, if you look at the strain.
Right.
Concerning pushing down, well, it's hard for me to say, in the sense that, well, okay, this was a theory estimate, so first we have to build the prototype and measure all the noise live, as people pointed out, and as I also said during the talk. But let's say I just want to be a theorist, then you should roughly improve as the square root of the quality factor. So also there, I mean, there is not really a hope of making like a huge leap beyond that line. I mean, unless we develop some amazing superconducting technology that can operate at very high magnetic fields. But we're talking about, like, I think, qualitative changes in the technology more than incremental.
Okay, thank you. Thank you.
Fernando, maybe I could share my plot. Maybe that's more useful.
Okay, thank you.
Can you see it?
Yes, yes.
Yes, so this is what I had. This is an optimization that my postdoc did for me, because this is how the formula looks like. And here you have the atomic mass. So you could, there's BCs that are made from rubidium, sodium, hydrogen. There's many different BCs. So you can, okay, well, the mass doesn't matter so much, but all the BECs have all other different sort of behaviors in terms of the, like the scattering lengths that are normal and the 3-body recombination and so on. So it's quite dependent on the species. We did this optimization with sodium. So what I mentioned as one of the projects that we're doing a review, and the review is because first we came up with an idea, then we studied how much squeezing you can create, then we studied sources of noise, and everything is like in different papers. And now we want to write like a review paper in which we put all the ingredients together. And sort of the new thing in that paper, apart from just putting the previous results in one single sort of result, is to explore different curves like this for different atomic species. And that's where I thought someone from your community would be really helpful in also, pointing out things like, well, you don't give you the sensitivities in terms of the characteristic amplitude, that kind of thing, give them in terms of the figures of merit that you use and so on. So this like I said, there's all these parameters here. Camila was asking me, why does it go that way with the frequency? And this really comes like in terms of the frequency, you have the sum of 2 phonon modes resonate with a gravitational wave, and the error goes like the square root of the product of the frequency. So that gives you more or less why you could get this sort of scaling. But you see, it depends here on the scattering length. So you could, these were using numbers of what experimentalists told me that they were doing in the lab, like sort of now, but I am still exploring how much could one push this in different directions. And also, again, if you did this not with a BEC, but with a different system, one of the ones I mentioned I wanted to explore are superconducting circuits and use like the same sort of ideas there. There might be some connection with what they were doing in cavities in that case. Then you could get different frequencies, because it depends really on what are your phononic modes. So the phononic modes go like the speed of sound divided by the length of the trap. So if you have a system that has a different speed of sound, then that will, and different sizes that that you can work with, that would give you a different frequency window.
Okay, and so you stop there at 10 to the 7 for a particular reason?
Yes, that has to do, well, I guess Dan just stopped at some point, no, but I think then the sensitivity starts to, I have to do this plot again so you see the whole thing, because we have many constraints. And the thing is, like, if we were going with that particular atom into higher, where are my constraints? They're not in this talk, okay. If you went to higher frequencies, then there were other constraints that were no longer satisfied. So for example, you need to be in the phonon part of the dispersion relation, and higher frequencies would take you out, I think was perhaps that constraint, or this probably is that one. So that's why we could not go to higher frequencies.
Okay. So again, close to the gigahertz and a few more is an ideal for you.
Yeah.
Okay, thank you.
Thanks. So I'll stop sharing.
I have a question, if I can ask.
Mike, yeah.
For Yvette.
Oh, for me.
Yeah, I didn't get a chance, but your detector is like a resonant detector with phonons.
Yes.
So so how does it get read out? There must be narrowband and broadband noise associated with that.
So there's different ways of reading it out, and let's say the most common one, this is not particular to my design, this is what people do with BECs to measure phonons and so on, is that the trap is released and they count the number of, they have like Chris Westberg, for example, has a camera and counts the number of phonons in each mode. And this is sort of a rudimentary because it's destructive and so on. Now with Philippe Boyer and my other colleague Divang Nayak developed a technique in which they put the BEC in a cavity that has light modes, and they can measure a single phonon change as changes in the frequencies of the cavity that they put around the BEC. So
So
we're
that'll
at
be
the
like a jump in phase space, I think. Right.
Yeah, well, Devang explained to me they get a change in the frequency, and he sent me a paper where they're looking at that. But the nice thing is that they can look at changes at the single phonon level. So yeah, with basically with Chris Westbrook and with Devang Nayak, we've been looking at different sources of noise that are relevant here, and basically you would have 3 body recombinations, so 3 atoms collide, form a molecule which is no longer trapped by the potential, and you lose it. That's the worst effect that we get from our calculations, and what that does is that it limits the time that the state lives. So we prepare a highly squeezed. So I think one of the things that I've noticed as a difference to other proposals I saw during this conference is that we squeeze the phonons into like a highly quantum state. I don't know if I saw that in the other proposals. I didn't see all the talks because I was like at the same time
I
in
think
another.
we have the potential to get ours into the quantum limit and do things like that, the acoustic bores.
I think that would help a lot, because if you enter
and so we're very interested in your work. We were reading it yesterday, Maxime and I, and we were thinking how we can apply this to multi-modes in the quartz Bohr resonator when we cool to 20 millikelvin and we get into the quantum limit
so that's where
might be a similar thing.
That's what I meant. We're mixing approaches. You know, it could be that you use my ideas of using squeezing in yours, for example, like a mixture of some of the things that I'm doing in mine. That so what I can tell you about mine could be interesting for you. If I take my phonons and I only leave them in a thermal state, so I cool them down as much as I can, and I just leave them at the coldest temperature that I have, which is basically just being in the classical regime, I get terrible sensitivities. Really, really, like, actually, it makes no sense to do that as a detector. In our case, it really amounts to having that highly squeezed state in order to do something, and that's where you get parametric amplification. Actually, I was studying before that was like Hawking radiation and things like that. So you have in the vacuum, you get these pairs, but if you have a driven parametric amplification in which you're throwing like a highly populated state instead of the vacuum, then you get like a amplified signal. That is what we're getting here, and maybe that kind of idea could be applied to yours or other of the proposals and might work.
Yeah, we thought about pumping. I mean, there was lots of proposals in the resonant bar community to do quantum non-demolition measurements when you got these cool devices cooled to the standard quantum limit. There's a literature out there. It's probably related, I would imagine.
What are the frequencies of your phonons?
5 megahertz.
Okay, I mean, I think that's the interesting thing, is that because you know the frequencies are different in the different proposals, then we can use ideas of the different, you know, let's say Weber bars in a way, and still span like a different frequency window. So the different proposals can in a way just complement each other, you know.
You should have some.
You have your hand up. Oh,
yeah,
sorry.
That's it. I can stop. Talk too long.
Axel, you have your hand up.
Yeah. I unfortunately have to join another meeting now on Alps matters because we have some optics issues. Therefore, I would like to come back to the strategic question a bit. So, and I think the previous discussion has nicely demonstrated how good it is to exchange views between different communities and what could be a spin-off. And in addition, I think we have this kind of strategic branch. So maybe for larger scale projects and for politics, but of course, as also, I would like to say we have to safeguard the small scale initiatives, that this is really not put into all the strategic issues, because it is just ongoing. And I would like to maybe propose that we collect somehow ideas for the strategic thing. So when are which reviews ongoing at different nations or European level where we might want to provide actively an input, that they don't forget about high frequency gravitational waves. I think we cannot wait for people approaching us. We have to be proactive. And we have done so for axions and in context of this update of the European particle physics strategy with some success, which was also important, for example, to get baby AXO on the road. And at present, we have a nice group at DAISY who is discussing internally the opportunities of high frequency gravitational waves, because we have also been of opportunity at DAISY to maybe change a bit the particle physics strategy of the lab. And for this, it was also very worthwhile to have your initiative to contact relevant people that will also contributed to talks and a kick-off workshop and so on. But maybe it's important to get an overview on where could we sneak in strategies for ongoing reviews somewhere worldwide.
Mm-hmm. Okay, that's a very good point. Yeah, Francesco.
Yes, so following on this strategic plans, we were wondering at some point whether it would make sense like to expand a bit our initiative and include at least one person from each like group working on this subject, at least from the experimental point of view. Exactly, also to be able to discuss the things that Axel was suggesting now. Be sure that we don't miss them. So, what do you think about this? Like, we could have, I don't know. So from DAISY we already have Andreas, but of course Axel will be welcome. We could have Yvette, we could have Juan, and whoever wants to join and help.
Sounds like a good idea.
Effort. Mike.
Well, I would like to help, definitely.
Me too.
Good.
Maybe
I
connect
agree.
with the quantum community as well. I can maybe help with that.
Good.
So it's out. So can people approach Francesco with these offers of help? I think that would be tremendous. Valerie?
Yeah, following up on this, I mean, I think depending on kind of how big is the interest, one could also kind of imagine a structure where, whatever it is, there's a bigger, let's call it advisory board, which, provides a scientific input that we need and make sure we don't miss anything. And then there could be like a smaller team of people who do the day-to-day work, right? Things like sending out emails, managing email list, organizing these conferences. So maybe if people contact Francesco, they could kind of also indicate what level of engagement they would wish to partake, right? Do they kind of want to get organized, really help with the daily work? I mean, it's not a huge amount of work, right? This is like not an Atlas collaboration, right? But do they kind of want to get involved also in the organizational stuff? Or do they kind of rather be kind of just wish to be consulted, say when strategic decisions are taken or when the next workshop program takes shape and these types of things?
On top of that, we also have the working groups that will include even more people working on various projects. Maybe at some point we should make clear who is in charge of which project, who is joining which project, and what are like the goals and the time frame for each of them. This is probably something that we'll do during the next weeks.
Mm-hmm. And then advertise that on the website, I guess, Francesco.
Again, it would be very useful if anyone who is interested could join the Google group, so that we have a list of emails.
Yes.
That we can use that channel to communicate, because otherwise every time we have to add emails by hand, and then we miss one of them, and it's a mess.
Okay, very good.
Yeah, and of course, if Raffaele or Diego want to add something to the list of working groups, because we didn't have time to add anything on that.
If there is interest in cavities in general beyond what we said, for sure, we can underline. I don't know if Diego is there, but I think he agrees.
I am, but I don't have any particular proposal.
Okay. Now,
can I make a suggestion?
Fernando.
Yes, just occurred to me, but for promotion, it would be nice, since precisely this was done at CERN. I know that they have the CERN courier or so that maybe we can contact people there from that they can write something about this workshop. Could that be possible, Valerie?
Very good idea.
Yeah, I'll look into that.
Oh, good. That would be very good, because that would be a way to reach too many people.
Yeah.
Yeah. Thank you.
Okay. Okay, Francesco, are we done with some ideas for the future direction? I think there were a lot of technical ideas as well as strategic ones, which I think just tells us how successful the workshop has been in bringing theory and experimentalists together. And I think there's also a third kind of animal that has appeared on the scene, and that is a kind of instrument theorist. So somebody who doesn't know which end to hold the soldering iron, but actually deals with the equations for detection. And I think we should encourage interaction amongst those, because I have a feeling that they are going to be important in the way forward.
Yeah.
So I pass over to you, Francesco, for the final words then, I think.
Well, I don't know if Andreas or Nancy want to say anything, since they're in the organizing group.
I mean, I don't have anything to say. I was listening, and everyone was already bringing up everything that was coming to my mind, so that's wonderful.
Yes.
Okay.
It's also my opinion. So I leave the floor to you, Francesco.
Okay, no, I think this has been a great workshop. So many interactions, many connections created, and that was the entire goal of this workshop. So I think we can be very happy, and hopefully this will. I mean, we can talk of these workshops in 30 years as the start of a nice journey. Say. Let's see what happens. Thank you, everyone, and I guess we will be in touch.
Thank you.
Okay, bye
Should
now.
we do another photograph, Francesco?
Bye.
Sorry, Nancy.
Should we do another photograph? And I was
right, before we leave.
If he had any advice on something that we missed in today's discussion or during the week.
I can't hear you well, but I think you're saying we take another photograph, right?
Two things. Photograph, and I was hoping can we hear from you if we have anything that we should be considering.
I didn't get the second part. Sorry, I can't hear well.
Nancy, maybe you have an echo.
There's
Maybe
an echo.
Maybe you can just write it in the. Maybe we can take the photo. In the meantime, you can write on Mattermost what you want to say, and then we'll announce it in a second.
Yeah. So please turn on the video. Whoever wants to be in the photograph.
And by this, you're giving your consent to be in the photograph.
Okay. More people joining. I see your comment. Let me first. I can go. Cheers. Okay, there we are. Oh no, we missed the Vangeros.
Don't worry about it. You didn't miss anything.
It's okay. Again.
Okay, Carlos. Disappearing. I can't see Carlos.
Okay, I think good enough.
I'm here.
Okay.
I'm here.
Yeah. Okay.
So
I think
let's also thank Francesco also, because
yes,
he does a great job.
Well,
yeah, thank you to the organizers.
Bravo.
So Nancy is suggesting to ask Joe if we missed anything during the meeting sessions.
I can say something. Can you hear me?
Yes.
Okay.
Yes.
I think someone has his microphone on, and there is some echo. Please.
Yeah, so I represent GWIC, so that is the Gravitational Wave International Committee. So that is a group that has representatives from, say, LIGO, Virgo, Kagra, LISA, also timing array, etc. So it's quite a sizable group. It's also a working group of IUPAC. Francesco gave a presentation for GWIC a few weeks ago, and we had a discussion about that. And contrary to some remarks that I heard, I think people are actually quite excited about this science. So the prospect of getting access to the early universe to do these first order calculations where you have on one side the Higgs fields coupled to axions, looking at gravitational waves at high frequencies. I think that is that excites many people. So I think that is well respected. The issue that we had in the discussions is how, first of all, how should we look at the community? How organized is that community? What are the plans of the community? Is there a roadmap? And also the issue of the experiments, because at the end, you would like to make some measurements and do detections. And we see various approaches. And the question is, so what is the optimal way forward in there? And in some sense, it reminded several people of the way where the experiments like LIGO and Virgo were in many decades ago. And certainly from our side, we would like to stimulate this as much as possible. So that is that. But then the question is, what is the best way forward and how to do that? So I heard some sensible remarks. I think the idea of going for a subset of some prototypes where you could encounter, maybe do some first measurements, see where the limits are, try to identify the noise sources, because also with LIGO and Virgo, we discovered many of them, and you have to overcome that. So that is, I think, where this workshop was very useful to try to set out a path forward. What I will do, I will report this back to GWIC. I will talk to a few people in this group here, and then we take it from there. But all in all, I'm excited by this science. But maybe again, because I come from particle physics, you never know.
Thank you very much, Joe. Thank you. It's very important for us.
Yes, thanks a lot for the feedback and everything. Yeah.
Yes, thank you.
Okay, so maybe we can conclude here.
Okay, well done, Francesco.
Well,
thanks a lot.
thank you, Michael. Thank you.
Thanks. Thanks a lot.
Bye. Bye.
Bye.
Cheers.